Welcome to IoT Boot Camp Day 4. Today we're going to be discussing how to add YAML documentation to your endpoints and thing points and use the Swagger UI to go browse them. We're also going to take a look at interoperability with other languages such as JavaScript and C#. My name's Craig Chapman. I'm a software consultant for Embarcadero Technologies. On the screen you can see my email address and my Twitter handle, as well as a link to my blog and the blog page which accompanies this session. All of the source code for any projects included in this session can be found on the blog page, along with any links and URLs used in the session. So we're going to get started today by opening up a project from yesterday, our endpoint, and we'll see how we can extend that with YAML documentation and how we can use the Swagger UI to go browse that documentation. We're then going to take a look at some interoperability options, connecting to our EMS REST services using HTML and JavaScript, and doing the same using Visual Studio and C#. It had been my original intention to include using Swagger CodeGen for this session to demonstrate how to generate SDKs for JavaScript and C# using an automated tool. Unfortunately, owing to technical difficulties working with that tool, I wasn't able to prepare that for this demonstration today. Once I have resolved those technical issues, I will of course update the accompanying blog post for this session. Instead, what we're going to do today is I'll show you how to build these SDKs manually for JavaScript and for C#. So I'm going to go ahead and open up our endpoint project from yesterday, and we'll take a look at how to add YAML documentation to it.
Okay, so now we need to add the YAML documentation to our endpoint. YAML is a documentation format it's a subset of JSON, so it's a human readable format. But it effectively forms the same function for JSON REST services as WSDL documents did for SOAP services, if you're familiar with those. So effectively it describes each of the available endpoints and method calls in a human readable and machine readable way. For more information, check out the wiki page on YAML, a link to which you'll find on the blog post which accompanies this session. Today I'm going to be using a tool called Swagger UI. Again, there's a link on the blog post for this. This is available over on GitHub, and this is a tool that allows you to open up, read and browse the YAML document which will be generated by EMS server. So I'm going to go ahead and download this as a zip file. And once I have that downloaded, I'm going to go ahead and open up my downloads folder here for you. And I'll extract the zip into a new folder. Okay, within that folder, I'm going to go ahead and browse in and go to the dist directory. And within here, we have an index.html. So if I open that up, that's going to open a browser window onto the Swagger UI, which is the documentation viewer. Now I'm going to go ahead and start up my EMS server without our endpoint in it. And the reason for that is I haven't added YAML documentation tags to our endpoint yet, which will cause the YAML document tool to fail. But for the moment, let's go ahead and open up in a web browser. We can see localhost 8080 version. I'm going to change this to API, and that will send back a piece of JSON which describes the available API documentation. And we're interested, as I've said, in the YAML, so that's API doc.yaml. So I'm going to go ahead and add that to the end of my URL. And this gives us back the YAML documentation for EMS server. It's quite a lengthy document already with nothing installed in the server, and that's because it's providing all of the existing functionality of that server in the document. So I'm going to take this document link and take a copy and bring that over into Swagger UI. Now, paste it in here, but when I click on Explore, it's going to fail to read that document. Actually, it hasn't failed, it's succeeded. But if on your system it does happen to fail, the reason is often because we're not hosting the Swagger UI. So what I've done is I've installed an extension into my Chrome browser, and the extension is called Allow Control, Allow Origin. And that gives you this little icon button up here in the browser. If you find that when you try to explore your YAML document it doesn't work, then you can use this plugin to enable, or rather disable and re-enable cross-origin resource sharing. The reason for this is that the domain, localhost, is not the same domain as index is coming from because we're browsing from file. So the browser security kicks in and prevents you from reading the document. Okay, so having read that document, we can see here that we have all of the existing endpoints for the EMS server. So we've got our API documentation, any edge modules that we have installed, groups, users, push notifications, and so on. I'm going to drag this to one side for a moment and we'll put some documentation tags into our code. Okay, so on our endpoint here, we have a get method which returns all records of the employee database table, and we have the get item which returns a single row. Now, we need to add some decorations to these, and I'm going to start by adding, I'm going to copy paste here because these are kind of lengthy tags, but I'm going to add some decoration to the get method. We're using two tags here, endpoint request summary and endpoint response details. More information about these tags can be found on the documentation at Embarcadero's .wiki, and again a link to this documentation will appear in the blog post for this session. So let's look at what I'm putting in. Well, the endpoint request summary starts with this first parameter here, which is actually called the tag, and all this means is where is the endpoint with regards to the server. So when I put the URL into my browser and I go localhost 8080, I do /employee, and that's why I'm putting employee, and here is the tag. The next parameter here is a summary, so a brief description of what this endpoint function is going to do. So I'm putting in all records, saying that this is going to return all records. We then get another descriptive entry here, so this is called description, and we can put a lengthier returns all employee records or something more with more detail. We then get this tag here for producers, and this is saying what does this endpoint, when I call it, what does it produce? Well, it's going to produce JSON text because we described JSON data coming out of DB select. So I'm going to pass back in the MIME type for application JSON. And then this final tag here is what do we consume? This is another MIME type saying what type of data do we get when the request is made. Well, this is a GET request and we don't have any parameters, so this isn't consuming anything. I'm going to leave that blank. It'll actually default to text type, but since there's no text coming in, it's not going to do anything. So that's describing the method. We then need to describe the response that this method will send back. Now, you could send back one of any number of different response codes. So HTTP has a number of well-defined response codes, one of which is 200. 200 means I made a request to the HTTP server and it came back successfully. So 200 is the OK code. So I'm just going to define for this method what happens if everything goes well. You could add in here response details for various error codes like 500 internal server error or 404 page or resource not found. But I'm just going to go ahead and put in the OK for this method right now. The next parameter of this tag is the data type that's going to be returned. Well, we're returning a JSON array, so I put in SP array. Now I could choose from a number of different options here. I could send back a straight Boolean piece of data or an integer and so on, but in this case I'm just sending back my array. So the next primitive format is, if I'm sending back an array, I'm sending back an array of what? I mean, I could just be sending back an integer or a string. So I could choose integer or string or byte or one of the other types. But in this case, what I'm sending back is an array, and it's an array of objects. Now, because objects aren't actually defined as a primitive type, I'm telling it none. We're not sending, I'm not setting a primitive data type for the return. I'm going to be setting an object, which is the next parameter. So I'm going to send back an array of objects. But then I need to describe that object. And because this is a single line tag, I don't have anywhere to describe it. So what I'm going to do instead is put in this parameter, which is going to reference a description of an employee object. That means that we need to define the employee object. So I'm going to do another little bit of copy pasting here. I'm going to put a constant string which defines my employee object. I can put this anywhere in my code, but I'm just going to put it up here at the top for now. So I'm basically saying this is my employee object, And the properties of that object are, well, I have an employee number, and the type of that property is integer. I have a first name, which is type string, and so on. So that's describing the object that I'm sending back. But how do I link it to definition's employee object? Well, for that, I need another tag. So I'm going to go and get, sorry, I'm calling these tags, they're attributes, and forgive me for the incorrect terminology there. So this attribute is going to be the endpoint object's YAML definitions. So I'm basically saying I'm going to add a definition into the document's definitions section, and the definition that I'm adding is CYAML employee. Well, that's my constant up here, defining employee object. So now my reference to the definitions section employee object is complete. So this is the complete documentation for this one method, but unfortunately, if I try to run this module without completing the second method, the YAML document will be incomplete and the server won't start up. So I'm going to go ahead and copy paste in the parameters, or rather the attributes, for the getItem method as well. So again, we have a request endpoint summary. This time I'm sending in employee/item. You remember that item is extended to our URL, so I'm going to send in the item on the URL here. I'm giving this a very quick summary, get employee record, so that's going to get a single record, and then the lengthier description returns employee record by number. I'm returning application JSON, and actually this parameter right here is not needed. I'm not consuming any data from the request body. Then we have the endpoint request parameter. So in this case, I am sending a parameter up. So I'm saying this is a T parameter in, and it's on the path, as in that is on the URL to our endpoint. And the parameter name is item. A description for that, specify the employee number. I forget what the true parameter is. I'm just going to quickly look that up. True determines whether or not this parameter is required. Well, for this endpoint it is, so that's true. We have T primitive type. Well, this parameter is of type string. That's what I'm accepting. Then we have the primitive format. Now again, I'm putting in none, and the reason is we don't have a string in here. If I put in none, it's going to use the default formatting of string, so that's going to give me a string return type, a string parameter type. At this point, we need to give the items data type. Now, this is accepted. This parameter looks like it's being accepted twice, and in the case of a simple string, it is. This parameter here is actually here for, as you've seen before, when we pass in an array, we can give the type of object within the array. So I'm just going to go ahead and pass in string. I believe I could pass in none at this point. I guess not. So I'm just going to pass in string and do the same thing again. And then we're being asked for a schema for the parameter. Well, we're not passing in an object, so we don't need to give it a schema. And we're being asked for a reference to a definition for the object. Again, we're not passing an object, so we don't need to push that in. Okay, and then we come to endpoint response details, and we're doing the same again. We're giving a 200 OK response. We're returning an array. The array doesn't have a primitive format. This should be an object. And we're returning definitions employee object. Now I don't need to reference employee object again because I've already referenced it here. So that's going to include that into the definitions section. So that's both of my methods documented. Let's go and see what that looks like when we explore it using Swagger. So I've started up my EMS server with our module in it, and I open the browser. And I don't really need to go through this piece again, but let's do it one more time. We'll go API doc.yaml, gives us the YAML definition. Now if I go and do a quick search in here for employee object, we can see that we're referencing employee object here, and this actually is our employee endpoint get method. This is giving us the summary and descriptions. You can see here that we're passing in 3 parameters. Now these aren't parameters that we've set on the method. These are parameters that are sent in the headers by the EMS server. So we can safely ignore these 3 parameters. This method has no parameters going in as far as we're concerned. And then in the responses, we've got our 200 OK, and we're referencing the employee object. If I take a look underneath that, we've got the employee object with an item parameter. And again, we're passing in these 3 header parameters as default for the EMS server. But then we're also passing in on the path, so on the URL here, item, which is to specify the employee number. It is required and it's a string. And then in the responses, we can see again I'm referencing the employee object. So if I search that employee object one more time, I'm not seeing it in our definition. Let me take a quick look down here. Okay, it appears it may be missing from our definition, so I'm going to go take a quick look at the attributes that we've put in here. And I tell you what I think needs to be done. I think I need to move this reference up here onto the class. So I'm going to go ahead and give that a try. Yes, so now I have 3 instances of this. This is my reference, and here is the object itself being pushed into our YAML document under the definitions section. So that's how we can reference definitions employee object. So now that the document's looking correct, let's go browse it in Swagger UI. So I still have this document open. Let's go ahead and hit Explore again to refresh it, and we can see now that we have an employee endpoint added to our document. So I'm going to go ahead and take a look inside the employee endpoint here, and I can see that we have one get method. If we go take a look under the get method, we actually have an example of what a return record should look like from this method. We have 3 EMS header parameters which we can ignore, and we don't have to put any parameters in. You can see returns all employee records being returned from the documentation, and so on. So if I go ahead and try this method now, we can see that it is returning all of the data from our endpoint. We got a response code of 200, and that's our response data. Okay, so let's take a look at the second version, the itemized, and we have employee/item. So I can go and take a look in here, returns employee record by employee number, and we can see that we have the 3 header parameters for EMS plus our item which is required. And I'm not going to look for item 5 again, I'm going to look for item 3 this time. I'm going to go ahead and hit try it out, and we can see I didn't get anything back, so there is no employee number 3. I guess I will try number 5. And here we can see we get Kim Lambert, and Kim's data come back from the method. Okay, so we've seen how we can add YAML documentation to our custom endpoints, but what about our thing points? Well, yesterday we created this EMS thing point, which reads data from a joystick and allows us to query that. The truth is we don't actually need to do anything to document our thing points. So if we take a look here at the resource that we built yesterday for reading the joystick, we added a lot of runtime type information tags. And these are used by the EMS server to generate basic documentation in YAML for our thing point. So I'm going to go ahead and start up our thing point here. I have our EMS development server running in the background. So when we start this up, I'm going to go ahead and register and activate this thing point. So this is now collecting data from our joystick and making it available to the EMS server. So if we take a look again in our Swagger UI, I'm going to explore our API again, and I'm going to come under Edge Modules, and we have a get method for getting the Edge modules which are installed. So I'm going to go ahead and run this, and we can see our EMS thing point is installed. Okay, so how do we get at the joystick data? Well, again, under Edge Modules, we have Edge Modules Resources, and we'll just check to make sure that under the EMS thing point, we have a version, API, and most importantly, a joystick resource. So now if we close up the Edge Modules section and step into the Edge Module Invokers, we have a get method here,
which says get a value from the edge module by module name and resource name. So I'm going to go ahead and come in here, put in our EMS ThingPoint module name and joystick as our resource name and try it out. And you can see we got two values come back, the X and Y axis of the joystick as it currently stands. Let's go ahead and I'll hold the axes of the joystick to one side and we'll try it again and see the different values that we get here. Okay, great. So now we're able to read data from our joystick using a REST endpoint. Let's see how we might build a HTML page which can display the data from our joystick. Okay, so now we have a ThingPoint working. Let's consume that ThingPoint using a HTML or web page. So this is going to be some plain HTML and some JavaScript. Now a lot of web developers like to use additional frameworks such as AngularJS or maybe Node.js, but none of these are actually required. You can use any of them for your UI, of course, but I want to show you that none of these are required. We can just use plain HTML. So to start with, I'm going to open up a new browser and I'm just going to check that our endpoint is working. I have the EMS server, the ThingPoint, and the management console running in the background. So if I go ahead and post in this URL, localhost 8080/edge modules ThingPoint joystick, we can see the X and Y axis data coming back. So it's a simple HTTP call. So I'm going to keep this browser open for a moment, and I'm going to go ahead and create a new directory in the subversion. So I'm going to create a new file. Now I'm going to be using Notepad++ just because this is a really great editor with some syntax highlighting. You can use any notepad you choose for this. And I'm going to go ahead and pin that up to my screen. So I'm going to start by creating a new file. I'll say save as, and let's browse to the directory that I want to save this in. So in the subversion you'll find it under simple HTML client, and I'm going to name this index.html, so it's the front page of a website. Okay, so we need some basic HTML in here, so I'm going to put in a HTML tag, and I should type it correctly. And we need a head section, and we need a body section. Okay, so in the head section, I'm going to go ahead and put in a script tag because we're going to use a little piece of JavaScript, and the script tag needs to be closed. So let's start by putting some content into the body. First thing I'm going to put in is just a hello message, and then I'm going to put in some paragraphs. So we'll have paragraph with an ID, and I'm going to go for JSON and close that paragraph off. Let's have another one, ID equals, let's have one for the X input and close that off. And let's have another one for the Y input. Okay. And then I'm going to need some way to make the JavaScript execute. Now I could do that on the load of the document, but I think I'd rather put this onto a button so that we have an event. So we'll have a button called type button. On click, we're going to have some JavaScript in there, but for the moment I'll just leave that blank. Click me and button. Okay, so I'm going to go ahead and save that file. So a very basic HTML file there with a couple of paragraph tags and a button. Let's open that up in our browser. And if I click me, nothing happens. Okay, so we need a piece of script. Well, I'm going to start this script as a function, and let's call it user action. So when I click the button, I'll call the user action. Okay, let's create a HTTP client. So I'll have a var x HTTP equals new XML HTTP request. Going from memory, I think that's right. xHTTP.open, and we're going to open a URL. I'm going to use the get method because we are calling our REST get method, and then I need to put our URL. Oops. So our URL for our endpoint in there. Okay, and then we'll use xHTTP.send to execute that call. Now when we get our results back, we need to display them somewhere. So what I'm going to do is use the DOM. I'm going to go for document.getElementById because we named some IDs here, and I'm going to pick out the JSON element there, and then I'm going to set the inner HTML
to the XHTTP response text. So we should be able to see what gets sent back. Now, in order for that method to be called, all we need to do is paste a call into the onClick event. So we're now going to call the user action, which should go off and call our endpoint and come back with some data. Let's give that a try. I'll refresh my page over here and click me, and we didn't get anything back, so let me check why that might be. I'm missing a parameter here, and I'm actually missing set request header. So we'll set the request header to application JSON. Okay, let's try that again. And this time we get our XML back. So we can see here that we have the x-axis parameter and the y-axis parameter from our joystick. So let's go ahead and put those into the x and y input boxes in our HTML. And we can do that just by manipulating the document a little further. So we'll start by getting a response as the JSON.parse, and we want to parse the XHTTP response text. So that's going to parse the text that we get back, and then we need to make use of that. So I'm going to go for document get element by ID in a HTML again. This time we're going to be modifying the X input, and we're going to be setting that to response.x-axis, because now that we've parsed the JSON, we have an object with an x-axis property. And so we can do the same again with the y-axis. Like that. So let's go ahead and test this. And we get our x-axis, our y-axis as a JSON packet, and here are the values. So of course we could put some additional text descriptions around this. So let's put x-axis and y-axis, and we'll get rid of the JSON at this point. We don't need to see it, that was there for debug purposes. So let's take that out. And I should put a BR in here. Okay, and we can populate our x-axis and our y-axis. So that's how we can call just using plain HTML and JavaScript. Let's take a look now at how we might call this from C#, for example. Okay, so I'm going to build a C# project using Visual Studio. This is Visual Studio 2015. And just going to go ahead and start a new project. This is going to be a Visual C# Windows, and I'm going for a Windows Forms application here so that we can see a form with our data on it. I'm going to name this Simple C# Client, and I'm saving it into the subversion directory of the same name, so you can go find that in the source code repository. Okay, so the default project created has a main form. I'm going to drop some components on here. Couple of labels, and I'll have a couple of edit boxes to return our values into. In fact, they're called text box 1 and 2, and I'll have a button to execute the request. Okay, so let's go lay those components out. Let's make these a little longer actually, because they're going to contain some relatively long string values. And then labels 1 and 2. Okay, so label 1, I'm going to change the text on this to x-axis, and label 2 to y-axis, and then the button, I'm just going to put the word go on the button. Okay, so now that we have the form, I'm going to create an event handler for the go button, which is going to go off and make our REST request. Now, I am by no means a C# expert. I'm actually quite new to C#, or rather, I've used it very little. So I'm going to be copy-pasting some code in here. And the first thing we need to do is include the using statements. So this would be the equivalent of your user statements in Delphi. So I'm going to add in system.io, system.net, and system.web.script.serialization. So I/O is for streams. We're going to use streams to collect the data from the web services. .net is for those web services themselves. We need to be able to make web calls. And this system web script serialization is for the JSON deserializing that we're going to do on the JSON data. Now you can see that this library is not identified. We've got the little red line under it, and that's because we need to go add a reference under references. As of .NET 4.5, I think, this reference is to system.web.extensions. Has a different name in older versions of the .NET framework. I think it may have been called system.web.scripts in older versions, but I'm going to need to go and add that into my project. So now that I have that, this little error should go away when we try to build. In fact, it's gone away now. Okay, so for the main event handler, I'm going to go ahead and copy paste code as I said, and here it is. So we have the HTTP web request, which is just a web request component, and it is calling our localhost 8080, edge modules, thing point, joystick. We're going to make this a GET request since we're calling the GET method again, and we're going to set the content type to application JSON. After doing this, we get a response class, so we call the request.getResponse to instantiate the response class, and then I'm creating a stream here which is going to read the response data as a stream, and it'll store that data into this string value here, this response string. Then I'm using a JSON serializer to deserialize, so I'm calling the .deserialize method to deserialize the content of the response string, and this is going into a dynamic object, so this is an object that's going to adapt itself based on the properties that are deserialized. And then I'm simply setting the edit boxes 1 and 2 to the values of the X and Y axes. Then I'm closing off the response reader, and this is all happening within a try catch. If something goes wrong, I'm just setting the text box values to error. Not a particularly useful message, but it'll suffice for this demonstration. So let's go ahead and save all of that off, and let's see this build. And it does, excellent. So I'm going to go ahead and run this application. And again, with the EMS development server and console and everything running in the background, if I click on go, it's going to go off and make that web request, and it comes back with our joystick data.
Okay, so as we're coming to the end of the boot camp now, I'd like to talk about some of the use cases and reasons why you might want to place logic in your EMS server. Centralization is one reason, of course, but there's also the issue of processing. So if you have a high amount of processing to do, you may not want to run that on a mobile device, which has a limited CPU relative to your server. And one slightly abstract, not really so practical example of this is L system generation. So this is something I started looking at several years ago, and effectively an L system is a mathematical system for rendering natural organic systems. So if you want to learn more about L systems or Lindenmayer systems, head on over to the wiki page here. But to give you an example, using an L system, we're able to have the computer draw things like this tree. And I'm going to show an example of something similar to this tree. So effectively the way an L system works is you pass in a starting rule, so in this case this would be the character X, and every time the L system processor finds the character X, it'll replace it with this pattern of X's and F's and X's and pluses and minuses and brackets, and every time it comes across an F, it'll replace it with 2 F's, and it'll do this in a loop with several iterations. It's actually a recursive iteration system. So what you end up with is a really long string of characters which you can then run through a turtle program to render as a drawing. So I went out and I found a JavaScript turtle which was written by a gentleman by the name of Bernie Pope. I couldn't find any license information on this, but as it's published and available, I assumed it's good for me to use it. But if you want to find the turtle code, head on over to his blog page here, And if we take a look under software and scroll down, you'll find JS Turtle. So we take a look at JS Turtle, and he gives some examples here. So we can give this turtle some instructions and have it draw things. So let's have it draw forward by, say, 5 units, whatever 5 units may be. Turn right by 25 degrees, and forward another 100 units. So you can see that this turtle is basically just following very simple instructions to render. And if you remember Logo from the 80s, I think it was, you'll be familiar with how a turtle graphics system works. So what I've done is I took the JavaScript and CSS from this turtle, and I created my own turtle client. I'm going to go ahead and pull the source code over now. And so what the client does when we call the do Lindenmayer function is it goes out to an endpoint, which I'm going to take a look at in a moment, called Lindenmayer, and it makes a call and has the server do the heavy processing of generating a string of instructions. When that processing is done, we reset the turtle's position, set the color, and then we start looping through the string of instructions that we get back from the server. And for each instruction, we do a different action. So for the F instruction, we draw forward by 4 units. For left and right, we turn the angle of the turtle by 25 degrees. And then we have the ability to push and pop values onto and off of a stack, so we can restore state to a previous state. So that's basically the client side of this application. It's going to render using turtle graphics onto a canvas inside of a HTML page. And of course, we've seen already the REST request being made from JavaScript. So now let's go and take a look at the endpoint that I built for this. It's called EMS Lindenmayer, and you'll find it in the subversion for this session. Inside the same directory, you'll find the client source code as well. And I've implemented a single method here. So I've got the get method. And what the get method is doing, I'm not actually accepting any parameters. I could accept, for example, the number of iterations, or maybe I could even pass up the rules and the axion, which is the starting character. But I'm just having no parameters go up, and I'm generating a default system here. And the system that I'm generating is actually that tree that we saw on the wiki page. These are the rules for it. And I set the axon, and then I call my Lindenmayer class, which is also included. And the Lindenmayer class simply runs through and processes the strings, and it's going to call process for each of the strings, and it's going to repeat that several iterations. So I've actually got this defaulted, I think, to 6 or 7 iterations, 6 iterations here. But you can imagine that while 6 iterations actually on this modern processor isn't going to take too long, if we were to put in 20 or 30 iterations for more complex systems, then that's going to require more processing resource. And in fact, I haven't tried it yet, but I am curious to see how well a ARM processor for a mobile device copes with this code. But for the moment, we're going to run this up on our server, and I'm simply going to return a JSON string containing result struct. So that's the result of running the Lindenmayer system. So let's go ahead and see this working. If I start the application up, it's actually an endpoint inside of our EMS development server, and I'm going to go ahead and open this in a browser, and I'm going to browse to the endpoint Lindenmayer. And when I do this, you can see that I get quite a lot of instruction text come back. So that's the heavy processing done. Took a fraction of a second actually on this processor, but that's the heavy lifting of the application done right there. And then if I go ahead and open up the example code, the turtle test code, we can see here my client application. And when I click on the Lindenmayer button, it's going to go off and make that call to the server. It'll get back that string, and it'll process it into turtle instructions. Now, in order to run this, I need to enable cross-origin. And when I hit the Lindenmayer button, we have a pretty tree drawn. Not quite the same tree as in the wiki. I think there might have been actually some confusion about the instructions in the wiki page, but this has been followed literally to the instructions there. So we have a tree rendering. So this is just one example of how you might do the heavy lifting on a back-end server. Now, if we were to extend that out, Imagine, for example, you are processing hundreds or thousands or millions of records from a database and trying to get a summation or some other function on that entire data set. What you certainly wouldn't want to do is transfer the entire data set down to a cell phone, which of course would use lots of network traffic. So if this is over a GSM connection, that could lead to quite a high bill. If it's over a Wi-Fi, it's still going to take a very long time. It's going to consume a lot of RAM on the mobile device. And then the mobile processor has to sit there consuming battery, running through all of the data to process the results. I'm not even sure most cell phones today could handle millions of records or even hundreds of thousands. So what we can do is we can produce an instruction on the cell phone, which goes off and calls our endpoint, have our endpoint do all of that processing on the server, and send back the result. The other advantage of this, of course, is if you should need to upgrade the hardware to handle higher data loads, higher processing amounts, then you could, of course, simply upgrade the server that your endpoint is running on, and you don't have to update or upgrade the client hardware. So, thank you for entertaining my little Lindenmayer demo there. You'll find that in the Subversion repository. Let's take a look at some more use cases. I wanted to take a moment to discuss what we've learned and to discuss some possible use cases for this technology. I'm sure that you'll have already come up with more interesting use cases of your own, but let's explore just a couple to see what we could possibly do with this. The first and most obvious is access control. So suppose you have a pin entry keypad and it's being monitored either wirelessly or by Bluetooth or by wire by a thing point. Well, that thing point can forward access requests onto an EMS server, which can then make a decision about whether or not access should be granted, and send a signal back through the same or another thing point to an actuator which controls the door lock, for example. So what is the advantage of using thing points and distributing this access control setup? Well, the advantage is that you can centralize the access control database. So you could have multiple pin pads and multiple actuators over various Wi-Fi ranges, Bluetooth ranges covering a wide area, possibly even at multiple sites, have them all talking to the same EMS server to make decisions about access control. Another use case might be to use Bluetooth beacons for access control. So to quickly disambiguate, EMS server is the actual server software that exists within RAD server. RAD server is a product bundle which includes EMS server, and it also includes Bluetooth beacon fencing. So with beacon fencing, you can track a beacon to within, I think it's an inch of accuracy on indoors. It's kind of like GPS for indoors, where GPS doesn't work too well. Beacons work very, very well down to the inch of accuracy. So you could track a beacon traveling around an office or a factory zone, for example, and make decisions by feeding that data through a thing point to a central EMS server about whether or not access should be granted. Another case is the home or office automation. And in fact, one area where we've seen some demand for automation is in the medical industry. So we actually have a nurse's station demo in which a nurse's application is running on a patient's phone. That phone is detected by a proximity beacon, which through a thing point communicates to the EMS server, letting the nurse know that the patient has arrived, sending a notification out to their tablet. When the nurse is ready to see the patient, a signal is sent back through the EMS server, which notifies the patient's phone, either by push notification or on the wireless network or some other means. The patient receiving this notification then enters the nurse's office, which means that their phone is again tracked by a Bluetooth beacon through a thing point to the EMS server, and once inside the nurse's office, vital statistics such as the patient's weight can be taken on a scale connected by Bluetooth, their heart rate on a heart rate monitor connected by Bluetooth, and all of that data is fed back to an EMS server so it can be stored on a central database. Let's now take a quick look at this demonstration in action with Jim McKeith.
This is a brief overview of the nurse's station demonstration. It all runs on an enterprise mobility server backend. The EMS server is running here. It has some existing users already created, but it is easy to create a new one too. The name is test and test, and then your name for the description field. It is really easy to administer. The next step is to run the nurse application, which is on the iPad here. This beacon represents the nurse's room. On the phone is the patient app. It says the patient needs to be in the waiting room to check into the hospital. So the patient goes to the hospital hall. This beacon represents the hospital hall. The app sees it and allows for check-in now. So the patient can sign in. And this sends an EMS push notification to the nurse's application. Now back to the nurse application. It shows that the patient has arrived. This provides his name on the patient list, so the nurse can select the patient when they are ready. Now the patient's application receives a notification that the nurse is ready for them. Here it displays, "You are now checked in. The nurse is ready to see you." So the patient can go to see the nurse. The nurse application is updated to announce that the patient has entered the room. Now the nurse can provide patient vitals like weight and heart rate via either the keyboard or via a Bluetooth LE connected device like this heart rate monitor. The app just connects to the device, and after a couple seconds of reading, the heart rate is entered automatically. The nurse just approves and saves the data. This is automatically updated on the central computer, which now shows the patient ID, heart rate, and weight. And that's all there is to it.
In large-scale applications, it's important to have technology which scales, and it's important that multiple teams of engineers can work together to produce the solution. With RAD Server, you're able to use Delphi or C++ Builder code to provide APIs for web developers or .NET developers to work with, among other languages. You've learned how to share your documentation for your interfaces with other development teams using the common YAML format that can be reused, and how to distribute your IoT devices over wider areas using thing points. You've gained an understanding of how to interface with IoT devices from your Delphi applications, and you've even seen that you can prototype and build your own IoT devices. With this knowledge, you can begin to integrate IoT into your own organization or provide IoT solutions for your customers. My name's Craig Chapman. Thank you for watching.
So there was a request here for the link to the blog post again, but it looks like you've provided that. Also, if you go to the main page, the embt.co/IoT Boot Camp 2017, that will link out to everything else as well eventually. So you can find it there. Let's see. Anything you wanted to add or elaborate on, Craig, before we get going here?
Yeah, I wanted... I said I'd come back to a question here actually regarding NoSQL databases or effectively non-relational databases. And in honest truth, I have very little experience with such databases. I've tended to always work with relational or unindexed tabular databases. My understanding, which as I've said is limited, is that in a no relational database, the concern with REST is the statelessness, and there are various discussions happening regarding practical applications of REST with non-relational data structures, but there seems to also be something of a misunderstanding that REST is stateless. Now, the primary concept between REST is that the server need not maintain state between two different sessions, but that doesn't mean that there is not state. Typically, the client manages a state, and it is, of course, possible to create state-based resources. So you could have, in things like authentication systems, for example, typically an authentication token is created, and that token sits in a database and can be accessed again by subsequent calls. So it's not like REST completely absolves you of state, and I think that's the primary leading concern. The other concern is that relational databases don't tend to send back record sets, but they send back a file. In a HTTP setup, that's not an issue. You can send back a file as a post data string or data stream. So that's a way to work around that as well. But that's about as much as I'm able to answer with my limited understanding of the problem. I could go and try and find some resources and update the blog with what I find. But yeah, I wanted to come back to that question because that was quite an interesting one.
That is interesting. It's one of those things, state is one of those overloaded words, so it means different things at different times. So REST doesn't require a state. It doesn't require a session, maybe that'd be a better term, but you can maintain state, like you said, through tokens or something like that. But the idea is that you're not having to have the overhead of that on the server side, which is common with most other systems out there.
That's right. And the other thing to remember is that REST actually as a communication mechanism or resource mechanism was conceived a long time before there were any actual practical applications of NoSQL databases. The idea of NoSQL databases existed, of course, but many implementations didn't exist. So yes, there's a possible conflict between the two technologies.
I know a lot of like background as a service, like Parse and Kinvi and stuff like that, use a NoSQL database like MongoDB behind the scenes.
Mongo.
Yeah.
Yeah, and so what they tend to do is, as I said, they send back files. Now so REST is about accessing resources, right? And every file is a resource. So as long as you have a way of referencing the file you want, you can get that resource back, and that then puts the processing on your client side to handle that data.
Right. Yep. And so with a NoSQL data, essentially you're referencing it by essentially a document or a file that's stored in the database by a unique key, and so you just say, hey, I want this unique key, and you get it back.
That's right. And the other thing to consider with NoSQL databases as well is, so the closest I worked on is Teradata, which technically is kind of a hybrid. It has both relational and non-relational structures. And the thing to keep in mind is that when we're talking about that, we really are talking about massive, massive volumes of data. I think in a lot of cases, the NoSQL's use in Kinve and Parse was perhaps to benefit the organizations running those clouds more so than the consumer.
So the question here about your use of C#, apparently sends a few people into convulsions. Sorry about that. Certainly everything you're doing could be done in Delphi, but the idea was just to show that, hey, occasionally you have to speak to people that do not have the benefit of using Delphi, and they may be stuck using something like C#, and so here's how you can interact with them.
Yeah, and so yesterday I actually demonstrated consuming an endpoint using Delphi, using the REST client components. So of course it can be done with Delphi. And I created quite a lengthy video series on my blog a short while ago where I live coded or real-time coded a complete solution, a complete REST solution using Delphi as the client side and actually using PHP as the server backend. So yes, Delphi is very, very capable, but this session today was about interoperability with other languages, and so obviously I had to use other languages.
So there's a question about licensing model around RAD server and EMS. Talk to sales. They're going to have a lot more information about what some of your options are about that as far as pricing and such, John. So
yeah, we have with various clients with different use cases where EMS and RAD server makes sense. We've discussed alternate options with them. So I want to say that effectively EMS, where the licensing does make sense, tends to be in more corporate setups, with enterprise. For mass market applications, the licensing really probably needs to be negotiated one-on-one with EMBT. And also be aware that there are many cases where EMS isn't the right product to choose, and generally your rep is happy to tell you that. As much as they would love to sell you licenses, certainly the guys that I work with in the North America office, they don't want to sell you something you don't need. So it's worth having that discussion.
it's one of those things that if I were to suggest things, then sales would be like, no, Jim, that's not the way it works. I'd be like, wait, sorry. You do your job, I'll do my job. What is the resolution of beacons? Oh, go ahead.
We're just skipping one here that I wanted to highlight as well. So I used a lot of attributes today in Delphi and in C++, under the C++ standards. Attributes mean something slightly different than in Delphi. So the honest answer is I don't know how to add YAML documentation to a REST service built using C++ Builder. I imagine it's possible. I have forwarded that question on to the relevant product people, and if I get a response back from them, I'll make sure to update my my blog post on it. But the truth is, I know how to do this in Delphi, and I don't know how to do this in C++.
Yeah, David Miller should provide a solution for that, but it is. I know it is supported, but I don't know the way of doing it offhand. Let's see. Oh, let's see the
axis of resolution of beacons.
Resolution of beacons, yes.
Yeah. So a beacon generates basically a radio field which is spherical, and the way that beacon fencing works is using the signal strengths and various parameters that we get in the Bluetooth packets. Something akin to triangulation is done. And triangulation, of course, works very, very well with three-dimensional data on a two-axis plane. But if you introduce the third axis, actually the third axis to some small amount interferes with the accuracy on the two axes, on the plane that you're measuring. So over 3 dimensions, it's not very accurate at all. In fact, technically there is no third axis in what we're doing. But what you can do is, because you are positioning your beacons manually, so I guess I should take a step back. So with Beacon Fence, what you get is a floor plan, and you can pin on that floor plan where your beacons are installed, and it uses that data to do the triangulation, to figure out where the particular beacons are being tracked. Now, what you can do is you could give a similar floor plan, but for a different plane. So you could provide your beacons and say, well, I know that this beacon's on the floor and this one's on the ceiling, and the difference between them is 2 to 3 meters, whatever it might be, and actually do the tracking on a second plane. And if you do tracking on plane A and then the parallel plane, you can do the calculation yourself to figure out exactly where you are in 3D space. But that's not something that Beacon Fence does. That's something that you'd have to add for yourself.
trigonometry.
I hope that was clear.
Yes. Use it. You do. Okay. What if we need to do authentication towards LDAP on employers using user database with using OAuth 2?
Sure. So my understanding of OAuth 2, you can call it, typically you can call an OAuth 2 server using HTTP, have your REST server make those calls, and forward that on using your own API. That's probably the way to do that. Bear in mind that RAD Server has its own authentication system, and there are various hooks that you can go into that authentication system and tie in other backends. So that's
Okay.
clear.
Alfred's asking a question about the heart monitor. There's lots of ways you could do that. If you've ever been to the doctor, they have things they use for checking up on you that are sterilizable or have covers or whatever. So there's different ways of handling that. Let's see. Here's a good suggestion from Francis. Could we expect to have a Swagger Delphi app generator?
I don't see any technical reason why not, but I don't know that that's anything that's been considered for the roadmap at this point.
So Francis, go to quality.embarcadero.com and put a feature request in.
Yes, definitely worth going to putting any feature requests and technical issues into quality.embarcadero.com. It does get watched. It does matter.
Yeah, they put a lot of consideration on feature requests to come out of there. So, okay. Well, I think we've gotten through most of the questions here. I'm just skimming through these again, make sure there's anything we elaborate on. Boyan is still on the line with us. If anybody has had a chance to play with some of the Vismeo or some of the stuff Boyan introduced on day 1 or day 2 and has any questions around that, certainly feel free to ask those questions now as well. This is the end of our IoT Boot Camp, and we're pretty excited about it. We've had a lot of fun working on this stuff. Hopefully you have too, and have made some interesting things. So if you do have any questions on any of the boot camp, feel free to ask those now, and we will get them answered for you. There's a question here about how to save the question list. I don't know that it's possible from the client interface. I actually can't even do it from my interface because I'm on the Mac. Okay, yeah, so I can't save it on my end. I can pull a report, but that's it. So I was saying in a room with cages for storing vertical line with 10 pages stacked. So one thing you could do, Alf, is you could put a beacon on each cage, and then you could just look at whatever cage you're closest to. Might be one solution for figuring out where you're at. So there's lots of different ways you could attack this. I would suggest getting a bunch of beacons and experimenting with it. I was talking to one person who was doing a solution with cows, where they had all these cows and they were using RFID tags, I think, before, and they'd have to scan the cows as they walk by, and they're looking at switching to beacons, putting a beacon on each cow, and then just setting a Android device or some sort of device on a stationary point, and it could just see the cows as they're coming into the in for the day at the end of the day. Let's see. Oh, here we go. Pat's saying to save a list of questions, click on a question, click Control A and Control C, or if you're on Mac, that'd be Command A, Command C. Let's see. Well, it doesn't work for me. See, so you can't do it on here, but apparently on Windows, if you hit Control A, Control C, you can copy and save all those questions off. You're welcome, Richard. Glad you've enjoyed this. Yeah, exactly. That's what we really wanted to do with this, is just kind of show a different look at a lot of things you could do, and hopefully inspire you to some new solutions on that. So looking forward to seeing everybody's great creations. If you do make, when you do, actually I'm not going to say if, when you do make some cool technology with that kit we had, make a video of it, post it online, share it on the community site, send us an email, whatever you want to do. Actually, you know what we should do? We should make a contest for people that are making cool Internet of Things solutions. Oh, I'm going to do that. Make a note. IoT video contest.
You know, every time you talk about making contests, Jim, I get slightly envious because I'm not allowed to join them.
Well, the contests are open. The public's voting on them, so I think they're open for anybody.
Really? If I can take part, I'll get on there.
Yeah. So I'm going to make a contest. If you go to Embarcadero or community.embarcadero.com/competitions, we'll have we have a couple competitions up there right now. We have the NASA API boot mashup. We have the T-shirt contest. We have the Cool Apps contest, and I'll add the IoT video contest, where I just want you to create a little video of something cool you've made with Internet of Things. This week you got so many cool stuff, so many cool technologies opened up to you, using Visuino, using the labs, using RAD server, using Arduino, using whatever. Just put it all up there. Oh yeah, we need to put a link to Pavel's Amsterdam IoT beacon code as well. I'll try and collect up a bunch because we've had a few other sessions on Internet of Things we can add to this playlist. If you go to the bootcamp homepage, we'll just link to everything. Okay? Raspberry Pi project book from Magpie has a project with a beacon on a greyhound dog that roams the office, monitored by a number of Pis. Oh, that's cool. So, yeah, that's certainly an option there.
A Sentry-based webcam on it would be nice.
Yeah, sure. Put a webcam on him. A few webcams. Get one of those 360 webcams. That would be great.
One application I was discussing with a client recently was they wanted to. They have a farm which produces things like fertilizer, for example, and they want to make sure that they have the relevant amounts of nitrates or various types of soil and what have you. And so the idea was to use beacons to identify each of the bins of these components, and then a tablet on, I don't know whether you'd call it, I guess, a tractor that is guided by the beacon fencing around to the relevant bins for the ingredients to build up these products. So yeah, it's a curious farm-related one, similar to your monitoring cattle. Temple Grandin would be proud, I'm sure.
Yeah. So Amit just asked if we could use Raspberry Pis and BeagleBones. Yeah, as long as you're using RAD server or Delphi or C++ Builder in there, as whatever you're using devices-wise and Internet of Things-wise, go for it. And we'd love to see what you guys are doing with this and be able to share some of that online as well. So fantastic. So I'm putting links. Look up another note here. All right. Great. Apparently the Control-A, Control-C worked, so that's good to hear. Unfortunately, it doesn't work on the Mac. Yes, Delphi, either Delphi or C++ Builder or RAD server or Interbase. As long as you're using one of those technologies in there, we'd love to see what you're doing with Internet of Things stuff for the contest. Okay, anything, Boyan, you'd like to say before we go?
Well, nothing at the moment. I just would like to thank everybody, you two guys, for helping, for working together to organize all of this and create all of this great content and experience for everybody, and the people that have attended.
Fantastic, yeah. And I'm just going to go on the record one more time and say if you've attended all 4 days of this boot camp and you haven't bought Visuino yet, I don't know what's wrong with you, because it's such a good price for such an amazing technology and such a great way to complement your existing Delphi development. So go out and buy Visuino. And Boyan's told me again and again he's not really too concerned about the sales, but dagnabbit, go buy it. It's just too cool not to. Like I said, I bought it when I saw it at the Code Ray just because it's such a great technology and communication lab to go with it. So that would be great if you go out and get that. You're going to, it's one of those things you're just going to appreciate that you have that technology. Or if you don't want to buy it, like Boyan said, you can use it for free. Just there's a few limitations on it, which are quite generous. Craig, anything you wanted to add before we wrap up today for the end of the boot camp?
I don't think anything to add. Just a huge thank you to everyone for participating and coming and joining us, and thanks to both of you guys for making it happen.
Absolutely. Yes, thank everybody. If you are not yet on Berlin, which I would imagine most of you would be, but if you're not, make sure you get on Berlin and get on update subscription so you can, well, I guess if you buy Berlin, you get on update subscription automatically, and then you can join the beta for the mysterious new release that is coming in the near future that includes something related to penguins. And yes, I'm being more cagey than usual. Get on Berlin, get on the update subscription, get on the beta, and there's just so much amazingly cool technology that is coming that you want to take part of, and clearly you are, the kind of person that is interested in the latest and greatest technology and all that's coming. Yes, there's an ability to run Delphi apps on Linux coming. Shh, it's on the beta. Get on the beta, Francis.
to talk about it. The first rule of Linux release is you're not supposed to talk about Linux release.
That's right. Although I'm not very good about following that rule, I talk about it way too much. So yeah, hopefully you're all on. If you're on update subscription, you're not on the beta yet, let us know, and we'll see what we can do to get you on the beta. Should be able to do that. There's a lot of cool technology coming, and you all want to take advantage of it and make cool stuff. So keep an eye out for the contest at community.embarcadero.com and join the beta. Get on Berlin. Get Visuino. Build cool stuff with Rad Server. Yeah, there we go. I think that's it. So thank you, everybody, for joining us, and we will see you around at some of our future webinars, I am sure, or contests or whatever. Bye, everybody.
Thanks. Bye, everyone.
Thank you. Bye.